Well, it's as usual a great pleasure to welcome a friend, Professor K. Subramaniam, to this lecture series on mathematics education in India. He doesn't need an introduction. I think whoever is here already knows him, but I'll just do my routine job. Professor K. Subramaniam served as a faculty and also a director of Homi Bhabha Centre for Science Education, which is a part of uh, Tata Institute of Fundamental Research. Um, he was trained in philosophy, did both his master's and PhD in philosophy, and then moved to the question of learning as well as teaching mathematics. More in school, but he works at all levels. But I have read his work more with school education. I was very intrigued by Ravi. Subramaniam is called Ravi, but all of you know it. I was really impressed by his deep training in Piagetian concepts to begin with, and also the way he was coming from both philosophy and mathematics and engaging it with questions that traditionally psychologists asked, which is about the classroom as a space of learning, pedagogy as a kind of dialogical possibility between learner, teachers, and all of the artifacts that's present in and outside the classroom. And uh, He actually advised NCRT, several other important bodies on school education, and continues to do so, and has very impressive list of publications. I know Rabi as a scholar all through, and was always impressed by his by the manner in which he engages with concepts. So, Ravi, welcome to this lecture series, and over to you. And thanks for accepting this in our invitation.
Thank you so much, Minati. It's a great pleasure and honor to to be a part of this series of talks. And thank you very much for the opportunity and also for that detailed and generous introduction. So let me start by saying a few things. I think the time available for the talk is roughly an hour plus, an hour and a half. Minty, is that right? Or is that how
Yeah,
long
we thought
expected
an
to
hour for the talk and then some interaction.
interaction? Sure.
But if sometimes, if the speaker and the participants want to go beyond 1.5 hours, we are fine. That's not an issue.
Okay. All right. So we'll target something like 1 hour.
Yeah.
But I would also suggest that you interrupt me at any point of time. You don't have to wait for the Q&A at the end. This is to all the audience. It's nice to see a lot of friends among the audience, and I'm sure they'll have questions or comments, and also the others. So you're welcome to interrupt me at any point, offering a comment, asking a question, clarification, whatever you wish. So we'll get started with, I have some slides which I will show, and I'll also explain what the outline, I'll give you the outline of the talk. So let me start sharing. Okay. All right. I don't know if it is sharing. Can you see my slide?
Yes, sir, we can see. Yes, we can see. We can see.
Okay, great. So let me, okay, I've lost the mouse. So let me just minimize this. Okay. All right.
Yeah.
So that's the title of the talk, which you all know, and that's the outline. So I'll talk a little bit in the beginning about my motivation for sort of starting work on this topic. And then I'll say a little bit about why data citizenship is important. Maybe this is a new concept for some of you, but of course, you probably already have an idea of what it is. And of course, it needs one to locate it within the relationship between citizens and the state in a democracy. And the other situation around us is that we live in a world shaped by data. So I'll say something about that. And then I'll just briefly talk about what I understand by data citizenship. And then I will go on to a couple of examples. So this is also going to be a kind of talk with examples. I hope to have enough time to spend on two examples. One is a data set. All of these are based on publicly available data, and they sort of illustrate activities, projects, etc., that could be done at the school level, typically high school level or even higher perhaps. So it looks at the data which is publicly available and gives examples of what kind of understanding one can get from it, what sort of studies or inquiries one can do. And this could even be done within the space of a school, maybe not a classroom, but maybe something like a lab. Of course, you will need some access to computers and so on. Some of it can be done on mobile phones and other devices, but ideally, one should have a laptop and internet access. So the two examples that I will be focusing on, one is about on the theme of economic inequality and goes to a database which is called World Inequality Database. So we'll do a little small exercise on that. And I want to spend a little more time, if possible, on this data, which is in the form of geographical information systems. So these are include spatial data with other kinds of data. They combine it. They're very interesting. And there are very powerful tools available in the public domain as well as large data sets. So I will give some examples of a couple of activities that could be done with these data sets and with the software. Okay, so that's the outline of the talk. As I said, please feel free to interrupt me at any point of time. Okay, my motivation for getting into this topic is primarily that, mathematics at the school level does connect with some other subjects like science, typically science. It has a natural connect with physics and to some extent maybe other branches of science like chemistry or biology, but it hardly makes any connection with social science. I mean, mathematics can be and is a powerful tool to illuminate social reality, to help us understand social reality. In fact, one could even say that mathematics, mathematical algorithms, and so on today shape our social world to a great deal. And so why doesn't mathematics education make any connect with social reality? And so when I started pursuing this question, one of the rather evident points of connection seemed to be the prevalence of data and the way in which data penetrates our everyday world, social relationships, social structures, and so on, how it shapes social structure. So I thought that data is something that can really connect mathematics education with social reality. And I started exploring this idea of data literacy at first, and then it led to this notion of data citizenship. We did a little bit of project of interacting with a community, trying to collect data of a more traditional kind through questionnaires and so on. Of course, that has very severe limitations, especially as a voluntary activity in a community. But today, sort of, I've returned to this theme after some gap of a couple of years. And there's vastly more powerful technology available, which can be harnessed for data literacy as well as data citizenship, and which is what I hope to show in this talk. Okay, why is data citizenship important? I think there are two aspects to this. One is that the fact that democracy, the role of citizens in a democracy is very important. Of course, this is not something that is something that is naturally there. One has to struggle for it because all regimes in power will want citizens to be docile, to behave in ways that suit them very much. And regimes in power will view citizens largely as consumers. Of course, the bigger the population, the better, because you can have a big market and therefore a big economy, and you can have growth. So, but this is only possible when people are consumers. So you look at the population as a large pool of consumers. And of course, it's also plenty of cheap labor, labor people who are ready to migrate from one place to another wherever they are needed, from rural areas to urban areas, etc. And they should not be too skilled because they should be able to easily shift from one kind of job to another. So typically unskilled labor, which should be plenty of it should be available. And this is to ensure that there's enough profit and enough production can happen. Of course, all these are subservient to large economic goals, which are taken as granted. The regime will also want very loyal voters who vote every time for the regime in power and not for the opposition, or at least if they're not very loyal, at least voters who can be swayed very easily, who can be manipulated and controlled. And you can, at best, the state will look at citizens as some kind of, beneficiaries of the government's largesse. I think there's even a Hindi word for it. I forget that now. It's okay. So, am I audible and is it all clear?
Yes, sir. You're audible. Yeah.
Okay. Yeah.
Your voice is clear. Yeah. I think the Hindi word is vote bank. I don't think it's a Hindi word, but yeah. Vote bank.
What is Labharti, I think, is the Hindi word.
Labharti, yes. Labharti.
Yeah, right. So now, of course, this bare citizenship is very different from citizenship, the meaning of citizenship in a democracy. Democracy means that the power is ultimately with the people. This must define citizenship, which is the relation between the people and the state. And in a democracy, the legitimacy of the state, of course, derives from the consent of its citizens. If you look at it broadly from the framework of a social contract theory. In turn, the state guarantees the rights of the citizens. It guarantees equality, justice, liberty, material and social well-being. Of course, the state may not be very successful in guaranteeing all this and in meeting its responsibilities. And then this will inevitably lead to conflict. This is broadly the sort of situation that most modern nation states find themselves in, including us. And if there is a contradiction, if the state fails to meet its basic the conditions of acceptability, then it will move over to control. So it will try to control information and public opinion. And since the early 20th century, mass media has been a powerful tool for propaganda, very well recognized in both in so-called democracies and in non-democracies. And it has been used by regimes in power to the fullest extent. Of course, 100 years down the line in the 21st century, information technology has placed vastly more powerful tools in the hands of those in power. You have the emergence of social media and the emergence of big data and surveillance and control. And these are the major threats to democracy in the 21st century. Of course, this is one side of the story. It's also true that citizens, people in general, also have access to these tools. And this access and the use of these tools to strengthen a democracy can be built up through educational processes. So in democracy, citizens are conceptualized, thought of as being active. So they're not merely exercising their vote, but participate in securing what they need. they contribute to shaping policies and governance, especially those that immediately affect their lives. Now, education, this is, of course, I was trying to look at it from the framework of this capabilities view, education as enhancing capabilities, which comes from people like Amartya Sen. And this includes capabilities needed for active citizenship, and data literacy is among the capabilities needed for active and participatory citizenship. Okay, so again, to just place it in a context, there was a long struggle needed to secure the right to information in our country. And in recent years, so many of you may know that the RTI Act has been continuously weakened, the whole legal framework through which citizens can access information. Even other sources of publicly available information which are important for policy and which typically were accessible fully to the public, these sources are also evaporating, or they're getting constrained and controlled or gated. So to take an example, the census has not been conducted for nearly 5 years. It doesn't look like it's going to be conducted. I mean, no steps have been taken to conduct it very soon. Independence of organizations conducting large sample surveys, like the National Sample Survey Organization, has now been dissolved. It's been replaced with some structure which is directly under the ministry and under the government. So there's no independence or autonomy. Even other autonomous institutions are either been stopped. Various surveys like the National Family Health Survey has also been stopped. So all of this is an indication that there is increasing control on the flow of information, even on the collection of information. And the legal framework, the laws, etc., are essentially becoming more and more oriented to tightening and controlling information flow. So these are all major threats to democracy, and the only way to push back is if a general wider awareness prevails about the importance of data and in fact, how essential data is and to a democracy and to democratic functioning. So that's one reason for data literacy and data citizenship. By the way, I've got my full screen here and I can't see any queries on the chat. So could one of you, interrupt me and
Yes, sir. Right now,
yeah,
there is no
let me
question.
know. Yeah,
Sir.
yeah. Okay, if there's any chat questions. So thank you. Okay, so the other situation or context to understand is that we live in a world shaped by data. And we are data consumers nearly every day, many, many hours of the day. Here is a very simple example. So if you are shopping and you want to look for, try to do it online, now more and more people in cities shop online. And then you look for ratings and decide what you're going to buy. This is a everyday example. If you want to go from A to B, you use Google Maps. Again, something that nearly all of us do every day. And this is also example of how we use data or we consume data. So the funny thing is that in both these examples,
लाइब्रेरियन मैम कहाँ मिलेंगे लाइब्रेरी
sorry, I don't think that was a query, so I'll continue. So not only in even these examples, you'll see that not only are we consuming data, but we are also creators of data. In fact, in the ratings are all by the public. So consumers essentially go and rate products. Even Google Maps harvests data and uses it to build these maps and to find the best route and so on. So so we are also data producers. But most of the time, I mean, sometimes you actively go and rate things because you're consciously doing it. But very often, say, like the Google Maps example, you create data without being aware of it or even without intending to. We are more like data instruments or data sensors, you could say. Of course, data and these ratings and so on can even become very large in our lives. So people active on social media, know how addictive it can be, and how much it can actually define your mood of the day or your self-image and so on. And self-worth is also a problem for young people. So number of likes, number of followers, etc. But life being so penetrated by data, which we could call data dominance, is not always helpful or benign. So here is an example of some news clip that, in fact, can have very disastrous consequences. So, and this is not an uncommon example. This is an example from some years ago, but such examples keep cropping up because of the other did not work, other identification, and so ration was not accessible, and somebody died of starvation, a young person. Okay. Now, we also need to understand what really is different. You see, human beings have been information creators for a long time, since the invention and use of symbols, and data has been collected also for a long time, but whoever wishes to study something systematically. So systematic collection of data is a part of science. And this, to take a very old example, Panini collected data about spoken language when building the science of grammar and linguistics in the 4th to 6th centuries BC. Should be 6th to 4th, sorry. Okay. So what is unprecedented is the creation of data out of everyday human lives. So what somebody has said, phrased it as the wider transformation of human life so that its elements can be a continual source of data. So this is the thing. I mean, even ordinary activities that we do every day can become converted to data. And this has really changed society quite a bit. It has led to new forms of value and new forms of economic organization, which has been called surveillance capitalism. So this is another aspect to data. Data has become, as some people have said, the new oil or the new black gold. And there's a new economic order that claims human experience as free raw material for hidden commercial practices of extraction, prediction, and sales. Because all of this has become hugely, the effects have become multiplied due to the entry of artificial intelligence and algorithms, etc., for classification, which can chew on this data, take it, and then produce something which becomes then commercially exploitable. So as lived experience is datafied, we ourselves or our attention is commodified and marketed. So there are many aspects to this, including what has been called an attention economy. So what really claims your attention, how much control you have over your attention, what you attend to, pay attention to, and how much of that control can be taken away and your attention can be directed to things which help the economy position you as consumers or in other ways. So one aspect also of resisting this whole datafication is to resist the capture and marketing of our own attention as a commodity. Okay, so there are many, many aspects which I think make data literacy very important and crucial. And how do we respond as educators? NEP 2020 says in its opening sentence, education is fundamental for achieving full human potential, developing an equitable and just society, and promoting national development. So what do we as educators prioritize and what do we need to prioritize? Of course, I think here the social condition is something that educators need to prioritize hugely. There's deep entrenched inequality in India, which is pervasive. Mass poverty is also a real threat. And the priority of education, in my view, is social transformation towards a truly democratic and egalitarian society. So with these priorities, with this context, I think it's hardly, one can't deny the importance of something like data citizenship. So now let me talk a little bit about what data citizenship is. Now, this word called data literacy is very current in on the web, for instance, and you can find it everywhere. And the notion of digital citizenship or even data citizenship is derived from that of digital literacy and or data literacy. So in a data-driven economy, a digital literacy or data literacy, I think use these words somewhat interchangeably, is advertised as a qualification for jobs. So if you look at courses on edX, of course, they wouldn't use the phrase digital literacy, but they would say data literacy. And you will see many courses on data science, etc., which are advertised as being, very good for getting jobs and so on. That which is true, of course. Now, data literacy is internet and computer technical skills, such as knowing good search strategies, understanding and using privacy settings, practicing identity theft protection behaviors, creating safe passwords, correctly citing online information, avoiding spam and e-scams. So this is one perspective on data literacy. So this is not really from the commercial point of view, but from the educator's point of view. One could have a definition of data literacy, which is just protecting how you interact with the world of data or with the digital world, how you understand privacy settings and protect yourself from harm due to security breaches or due to people stealing data and so on. So this is one meaning of data literacy. I think there is something in the chat. Is there?
No, sir.
Okay.
There is no question.
Okay.
I will update you once there is a question.
Yeah, sure. But the idea of data citizenship also derives from the idea of critical literacy or critical data literacy in our context. And here, I've taken this definition from this Oceans of Data Institute, which is the data literate individual understands, explains, and documents the utility and limitations of data by becoming a critical consumer of data, controlling her personal data trail, finding meaning in data, and taking action based on data. The data literate individual can identify, collect, evaluate, analyze, interpret, present, and protect data. So it's, if you notice here, so it talks about many different things. One is sort of consuming data with understanding. So looking for data, gathering data which is available, understanding what it means, maybe processing it. That's one aspect. But also equally, creating data. I mean, we are creating data in some sense unconsciously, but even in a directed way, in some way which helps us sort of increase our democratic participation or participating in society or improving our lives through some kind of collective action also. So this is not only something at the individual level, but also something which is oriented towards a community. So data citizenship is derived from the idea of critical data literacy, digital citizenship, and so on. And broadly, one could say it is to do with resisting data totalitarian tendencies and recovering democratic agency and power through civic action, which is powered by access to data and ability to process and understand it. Okay. It's also connected to this very nice phrase, which is called reading the world with mathematics, or reading and writing the world is also the phrase used. It's taken from Eric Gutstein. And mathematics is powerful since it allows us to read the world, that is to understand the hidden ways in which it works. A large part of data literacy is concerned with the ways in which mathematics is used to format the world that we live in. So underlying this entire thing of data prevalence and data domination, you will find that a lot of what underlies is mathematics, mathematical algorithms, mathematical definitions which categorize typology, categorize various types of data, and of course process it. So all of these is it's important to understand what is going on here. So what kind of data is collected? How is it processed? What inferences are drawn from it? What actions flow from it? And what effects does it have on different people? So mathematics education cannot ignore this domain, and data literacy is also connected with statistical literacy, which
So,
is around
uh,
for a while. Yeah.
so there is a
Okay.
question from Anushri.
Yeah.
She has asked, you can respond it now or you can take it later also. She has asked, how can mathematics education help students or people in general to be prepared to engage efficiently and carefully in such a data-driven world?
Okay.
She has
Right.
sent a direct message.
Oh, okay. Not okay. All right. So I
As
can't. Hmm.
I
So
will
she's
share in
asking,
the
how
meeting.
can mathematics education respond to this? Is that right?
Yes,
Yeah. So
I will
that's what
make.
the talk is about. Just hold on. I'll give you some idea. Of course, it's quite a large thing, and then yeah, as educators, how can we respond? Of course, it's one thing to engage efficiently and carefully, etc. But another thing is that what are the skills, awareness, and understanding that we need to build up, and that's where I think educators can help. So let me get back to thing, and that's what this talk is about. Thank you for that question. Okay, so all right. So now I'll come to my first example, which is economic inequality. And let's just understand, I mean, of course, India is a very unequal society, and we'll see that shortly. Inequality is a potent threat to democracy. In fact, Ambedkar, as the main framer or drafter of the constitution, warned that democracy without socio-economic equality can fail. So it is one of the threats. And it's important to keep this question in mind, that can democracy really function where there's deep and widespread inequality? And then the question also is, how unequal is India? Uh, One of the things, I mean, this is something which hit many of us during the COVID pandemic, because inequality means that crisis, the impact of crisis, not just everyday living and so on, is very different on different groups of people. And crises affect the rich and the poor very differently. And crisis can also increase the inequality. The COVID pandemic is a good example. It sharpened the inequality in India and in many countries. So, as some of you may be, I mean, most of us are aware that millions of people in India lost their jobs, had to walk hundreds of kilometers to return to their home states. Those are all harrowing images when we recall them. Of course, now it's a bit faded in memory, but the effects are still there. Recovery was slow and incomplete. But the strange thing is that the wealthiest people increased their wealth during the pandemic, and their wealth continues to increase. So other shocks to the economy, not only the COVID pandemic, like demonetization, the introduction of a new GST system. Of course, some of this were avoidable. Some of them were maybe inevitable, like the COVID pandemic. To some extent, they could have been managed better, but these are things which will happen. Even the GST system, it is more a question of implementation and so on. So but it hits the poor much harder than the rich. And so inequality is something that uh, can keep getting worse. And it's something that one has to actively tackle. And it's not going to be tackled just on its own. It all needs a struggle on the part of the dispossessed, on the part of the marginalized, to reduce this sort of inequality. And so it's something very important for us to understand. Okay, so how do we perceive and understand inequality? So what I'm going to focus on is economic inequality. There are many kinds of inequality, such as social inequality and so on, which can mean difference in social status, in the kind of access you have to resources like space or transport, mobility. There are many aspects to inequality. one's own self-worth, all of this, but a notion of humiliation. But what I'm going to focus on is economic inequality, and I'm just, point out the sort of resources and that are available to understand inequality, and especially one important resource. Here's another way in which one can understand inequality within sort of mathematics education framework. And this I've called the maths of scaling. So here is an example of a scaling, which is done by just invoking the notion of proportion. So the Earth is about 4.5 billion years old. Of course, the universe itself is about 12 billion years old. Now, if the age of the Earth is scaled to 1 year, when did humans appear? I think many of you know this scaling example. So do you know when humans appear? You can use the chat and Varsha can read it out to me if you're putting it in the chat. Any idea when humans appeared? Very late in the year, maybe sometime in December. Okay. Life, on the other hand, appeared very early. So January 1, the year started. Life appears on February 25th. Reptiles appear on December 6th.
Ravi,
Yeah.
a lot of people, a lot of our participants are writing that slides are not changing. So have you changed the slide or we are
Oh,
still?
yeah. Can you see what slide I'm on now?
The mass of
So
scaling.
now we can see
Now it
the
has
maths
changed.
of scaling.
Okay, yeah. So now can you see the same slide?
Yeah,
Yeah, okay.
just the top.
Yeah.
Caption.
Can you see the slide changing? Earth is about 4.5 billion
No,
years
no,
old.
only the heading, the maths of scaling. Only the heading.
Okay. So this animation is not going through. Okay, so let me just show it like this. All right, I think this is visible enough, right?
Yes.
Yeah. So if the age of the Earth is, so you can see that reptiles appear on December 6th, the dinosaurs become extinct on December 25th or Christmas Day, and Homo sapiens, which is the modern human species, appears only on December 31st. Right? So
Yes,
this is,
Chandra has written December and almost.
yeah, right. December 31st at just 4 minutes to midnight. So it's like really, we can understand that humans have been here for a very, very short time. And of course, so something like environmental damage becomes all the more stark when you think of it in these terms. Okay, now let's look at the mathematics of inequality in terms of economic inequality, and let's apply the scaling to this. I don't know if you can you see this now? This sentence about the auto driver, can you read
No,
it?
sir.
No, it appeared and then
Ah,
left.
okay, all right. So, all right, doesn't matter. So, but I
Now we
have
can.
questions for you, which I should, let me see if I can use the PDF in that case. Yeah. I don't want everything to appear at the same time. And okay. All right. Okay. I think you can see this now. Maths of inequality. Is that
No,
visible?
sir.
Oh dear.
You can only see the title.
It's only the title,
We can only see
not
the title.
the other contents.
Only the
Okay,
title, the maths of scaling.
I see. All right. Let me try once again. Sorry, just give me a minute. Okay, let me just try this. You can see this, right?
Only the title.
Yeah, no problem. Now you can see this, right? Auto driver earns about 25,000.
Yes, sir.
Yeah, okay,
You
great.
can see the first line.
Yeah. So I've made an estimate here. Let's say an auto driver earns about 25,000 a month. You would agree. Because when we talk about inequality, economic inequality particularly, there are two ways of looking at it. One is sort of based on income, and the other is based on wealth. Wealth means what I own in total, all forms of wealth, money, bank deposits, real estate, etc. And income is what I earn, say, every month. So, but these are strongly correlated, and you can say that an auto driver, say, if he earns about 25,000 a month and works for about 25 years, he accumulates a wealth of about 25 lakh. So I hope you sort of agree with this. And IT engineer, let's say in Bangalore, earns about 2 lakh, say, who's worked for 5 years or so. And in 25 years, so this 2 lakh is about 8 times what the auto driver earns. And then in 25 years, you could say accumulate some 8 times that amount. So it's about 2 crores of savings, let's say. Maybe a little more. I think I'm underestimating that, but let's say about 2 crores. So this is clear. You have any comments on this? Does it seem reasonable or approximately okay? Okay, so let me go ahead. Now, the top 2 wealthiest Indians have a wealth of about 10 lakh crore. This is fairly recent data. It'll go up and down a little bit, but it's around 10 lakh crore. And this is a huge amount of money, as you can understand. So if we ask the question, so 10 lakh crore, how do we understand this kind of inequality or this amount of money? And so let's apply the maths of scaling. So we can ask how many years does the IT engineer have to work to accumulate such wealth? So we know that if you work for about 25 years, you accumulate about 2 crore. So in order to accumulate 10 lakh crore, how long would you have to work? So if you can do the scaling. So in about 100 years, one accumulates about 8 crore, say 10 crore, right, in about 100 years. And so 10 lakh crore would mean so 1 lakh times more than that, right? So it comes to about something like 100 lakh or 1 crore years. I hope I'm right on that. So this is a kind of gives you an idea of the extent of wealth and the vast difference, the sort of wealth that rich people have. And this is, of course, taking the Indian example. Okay? And it becomes much worse when you think of what the auto driver has to, how long the auto driver has to work to accumulate that kind of wealth, or even to accumulate the sort of wealth that a typical IT engineer or a rich person accumulates. Okay, this is inspired by a video which is available on the net. So let me see the chat. No, can't see it. All right.
So there is some discussion in the chat about the question, auto driver question.
Yeah. Can you tell me what it is?
So Mohammed Abdul Shakur writes that, did I miss something? He did a calculation that if an auto driver earns 25,000 per month and works for 25 years, then the total wealth should be 25,000 multiplied by 12 multiplied by 25 means 75 lakhs. So another writes 10 million. Then Jayashree ma'am has made a comment that house rent, children's education, medical expenses, if we expect an auto driver to save a lakh per year, it is about 8,000 per month. Do we have do we have reasons to believe an auto driver can save so much? So yeah, so there is some discussion. And Anushri said that IT engineer, even without spending a single rupee, would need more than 41 lakh per year to accumulate the same wealth as the top two wealthiest Indians. So yeah, there is some discussion going on in the chat.
Yeah, right. Of course, one always has to spend some money. So there's a certain ratio of income to wealth and over what period of time that wealth accumulates, which I've used. I mean, I've tried to make some guesses and estimates. One can make it differently. And, we also know from talking to people that if somebody has a steady income, then, with over time, with hard work and a lot of savings, etc., you could buy a house which might cost roughly something like 25 lakhs. So you have that kind of asset with you. So that's the kind of estimation or guesswork which has gone on here. But you could do it differently. It won't change the ratios much. You will see that it's still something quite mind-boggling, the amount of inequality that because wealth determines income. I mean, it's kind of there is a certain proportion between wealth and income, which remains the same across the economic strata. So it's quite fair to compare wealth at different economic strata and also think of it as some measure of income inequality. Okay, so let me go back to sharing. That's just one example of how one could discuss inequality in the, say, from the mathematics framework, or maths education framework rather. Now, I have some question for you, which is that suppose you want to have the India of our dreams. Right now, many of you have commented, started thinking about this. So to answer this question, think slowly and carefully about how much you earn. Of course, I'm not going to ask you how much you earn and how much you would like to earn, etc. And then you answer these questions. Okay, so you can put your answers in the chat. So what is the bare minimum a person should earn? So let's say that the person has a family of 3 adults and 2 children, which is quite common even in cities. It's a kind of unit, 2 people, a couple who's married, 2 children, and somebody they're taking care of, maybe an elder person or maybe a relative or maybe a young adult, whoever it is, or someone who's not well, who's ill. So you could say 3 adults and 2 children. This is our family unit, typical one, just for purposes of discussion. So what is the minimum that a person, and let's say that 2 people are earning in this household, which consists of 5 people. So what should be the earning per month to sustain oneself? What is the minimum that you think one should earn? I mean, based on your expenses, how much you spend, etc. Assume that many of you live in cities who are attending this talk, Delhi, Bombay, Hyderabad, or Bangalore, or somewhere. And so what is the bare minimum? So let me close this and look at the chat to see if any of you have volunteered any figures. Marsha, you want to guess something? Okay, someone says at least 50K, 50,000 for a family of 5, which means if 2 people are earning, average 25,000 per person. Okay. All right.
I think at least for my personal opinion, I think between 75,000 to 1 lakh.
75 to 1 lakh. Somebody says 30,000. Okay, someone has said 1.5 lakhs. All right. So we've got at least 60. Okay, that's a kind of very conservative estimate, 50,000, 60,000, 50K per person. Oh, okay. That's 1.5 lakhs for 3 adults, assuming that the children don't earn. So per adult, let's say average. So we usually divide the family income or the household income by the number of adults to get an average per adult. Okay, so 50K per person. So you can see this sort of estimate. All right. Now, this is useful. Let's go back and keep that in mind. So I will also try to remember that on average or somewhere in the median value that you all predicted is needed is about, let's say, about 75,000 to 80,000. That's my understanding of what you all said. Okay. Now, here is another question. So we take a person who's exactly in the middle of the population. Now, this is what we mean by middle class, right? I mean, maybe I should ask this question first. So let me stop this and then ask, how many of you among the audience think you're not part of the middle class? I think all of you think of yourselves as middle class, right? More or less. No?
Yeah.
Okay. I can see. Yes, yes. So people say, me upper middle. Okay. Somebody says yes. Varsha said no. So Varsha? Okay. All right. So, I mean, I have asked this to many different kinds of audience, and they all say, yes, with the new GST coming, we fell in middle class. Someone says, all right. So you all think of yourself as middle class. And you've also given me an idea of how much is the minimum that a person should earn in India. Now, what do we understand by middle class? I assume that middle class means someone who's in the middle of the population, right? One way of systematically doing this is that you take the population and split it into 5 groups. They're called quintiles, right? So by you arrange them and you put them in order of income, say, and then you take the top 20%, you call them the rich. The next 20%, you call them the upper middle class. The middle 20%. So you get five bins or 5 classes, and each of them is called a quintile. Quintile means 5 parts. And the middle one would be middle class, then lower middle class, and poor. So poor, lower middle class, upper middle class, rich. Right? I mean, this is a fair definition of a middle class. Would you agree with that? Okay. So now let me go back and see what I have on my slides. So what is a fair income for a person who's among the top richest? Okay, this is also an interesting question. So how much should a person who's in the top 10%, let's say not 1%, so it's top 10%, how much should that person get? I'm looking for some answers in the chat. I think here the imagination can run wild. And let's see what people say. How much should a person in the top 10% bracket? So this is even among the rich, you're taking the upper half of the rich. 5 lakhs per month, okay. Top 10% is 5 lakhs per month, okay. That's Jayashree. Anybody else wants to hazard a guess? 2 crores per year for a family of 5. 2 crores per year translates to 200 lakhs, which is about how much is that? 20 lakhs per month, roughly 18 to 20 lakhs a month, 18 lakhs. 1 crore a year, which is about 9 lakhs per month. Okay. So, all right, 8 to 9 lakhs per month. All right. So, good. So, we have some estimates here. Keep that in mind. And let's see if there's some data on this. Okay. Here is So which class do we usually think we belong to? And the concept of quintile I spoke about. So similarly, there's decile and percentile. So decile means taking the population and splitting it into 10 parts. Percentile means taking the population, splitting it into 100 parts. And how do we define middle class? We take the middle, and quintile is useful for that. Now, how much income per month does a family of 3 adults need to have to be in the middle class? So you all told me what is the bare minimum, which is about 80,000, if I remember, 3 adults. So to be in the middle class, I assume would be a little higher than that. Would I be right in that? So maybe 1 lakh is what you would all think. Family of 3 adults earning 1 lakh, which means about 33,000 per person, per adult, would be a reasonable income to be in the middle class, is my understanding of what you as the audience is guessing. But maybe a little I am underestimating. Maybe you feel it should be 50,000. That's what many of you said, 50,000 per adult. This thing is a minimum, but I'm assuming maybe that's like also the definition of middle class. Okay. So now we do have some data on this, and there is a very nice website which has all kinds of data, and I'm going to go to that website now, and that's called the World Inequality Database. So let me share that. So is this visible, this website? You
Yes,
can't
it's
read
visible.
you can't quite read the top, I think. It's okay. It's called World Inequality Database. Now you can read it. So WID.world. It's very easy to find on Google. And you have many different kinds of data here. For instance, there are country graphs, and you can click on that and you can get the data for different countries, including India. But I'm going to go here, which is an interesting section, which says, where are you in the income and wealth distribution? So let me click that. And it asks, I think it's guessed that I'm from India, but I don't know. Let me see. So where are you in income and wealth distribution? So let's say I want to do by income. You can also do the same thing by wealth. Okay, it's asking for the country. So my country is India. All right. And this is my currency, Indian rupee, which we all know. And what is the income of your household? Okay. So now we have assumed that we are in a household of 3 adults and 2 children. So, and what is the income? So I'm going to put in 1 lakh, but I think middle class means something more. What should I put, Varsha, for middle class income for 3 adults?
Around 30,000 for 3 adults, 75,000 to
75,
80,000.
which is the minimum you said. Now I want to guess for middle class, because many of you said you're middle class. So I want to put a figure for, should I put 75,000 only?
For 3 adults, I think 80,000.
80,000 for middle class. Okay, so let me put that 80,000, which I think, so per month, and I think it's a bit low. What do others think?
yeah, I think it's a bit low.
Bit
1
low,
lakh.
About 5 lakhs or so, or maybe more.
more than 5 lakhs. Okay, let me put just 1 lakh.
Yeah.
Okay, just a conservative estimate, and enter this. And how many adults live in your household? So it should be 3 people. So let me enter this. And now we should get something in the middle of the population, right? And maybe a little on the lower side. Is that what you would say? Where are you in this? So you can see at the bottom, there's a scale, and we should be somewhere in the middle. So let me enter this and we can check. So here is a surprise. So if you're getting that much of money, 1 lakh for 3 households, you're in the top 22% in India. So you're actually among the, not even the upper middle class, but bordering on the rich. Is that a surprise?
It is a surprise.
It is a surprise, right? So those of you who are earning, so if you've got only 2 adults and you have an income of 1 lakh, so let's put that in. So, sorry, I shouldn't have gone back. Income, India, Indian rupee, and say I've got 1 lakh per month, and I say 2 adults, and then where am I? So you're in the top 11% of the population. So this is interesting, and you can see that this is average income at the 50th percentile, which is exactly in the middle. Average income is 20,000 rupees per month per person. So this is the sort of reality. So if there are 2 adults, the family earns only about 40,000 per month. Of course, this is the database is based on various kinds of estimates, but of course, good estimates. They're very careful about their methodology, and they have a methodology which is comparable across different countries. So it's good to know this to compare also in various other countries. And this is a so gives you some idea of where the population is and what is really the income and where you are in the population. And we tend to think of ourselves as middle class, while we actually are among the maybe even in the top 20% or sometimes in the top. Okay, this one is the top 11%, right? Okay, so now, of course, this is a kind of understanding of it from an individual point of view. We also have indices or measures of inequality. And this is also something mathematical. So let me, we are already 1 hour into the talk, right? Okay, so maybe I will skip that exercise of finding something called the Gini coefficient. We will, so 90% of the population is earning less than 20K. No, that's not right, Gina. So this is, it's 50% of the, that is average per adult. Household may have divided by 2, the household income. Okay, so let's move on to another kind of, so this World Inequality Database has all sorts of things. And I will just show you this, just the sort of graph of the, this is an exercise which you can do, which is to calculate the inequality coefficient called the Gini coefficient. And then the Gini coefficient for India based on data from this World Inequality Database, which you can collect quite easily. It comes out as 0.62 or 62% or whatever, which is quite high, which is very high in the world. And if you look at Wikipedia and so on, you get an idea of where is in India in the inequality map on the world. In fact, this is another measure of inequality. How much is earned by the top 10% of the population, how much the bottom 50% earns. So I think this is the 10% versus the 50%. The blue line is what the bottom 50% earns, and the red line is what the top 20%, top 10% earns as the share of the total income in the country. And you can see that the gap is widening over the years, and the dots are estimates. The bold lines are actual, more reliable data, and maybe it's going down in recent years. But of course, the data has also become a little shaky in recent years. With that caveat, you can look at this. Okay, so now I'll go to Minati. I'll take about 10 minutes. Is it okay?
You take 15 minutes.
15 minutes.
We'll extend the session, don't worry.
So I want to talk about a completely different sort of data, which is also very powerful and available publicly, and some software which is also available associated with it, which one can use. So this is the data which is called geographical information systems. It integrates spatial location with other information. For example, you can have things like population density, resources available at particular locations. All of this can be very easily put together with the geographic coordinates and so on. And Google Maps is a very good example we are all familiar with of a geographical information system. Of course, we are only users. We only see the user interface. So now we're going to go a little bit behind this user interface. And in the maps, you can see the map itself, which is the geographical region. And you can see a number of features, hospitals or shops or bus stops or whatever. And you can even see additional information like how many people have liked it or recommended it if you click on it. So lots of things, including routes, shortest routes, information about public transport, lots of information is available, which is put out on a map. And so this is an example of a geographical information system. So GIS data can throw a lot of light on access, availability of public goods at specific locations to specific groups of people and so on. So I'm going to show you some examples of that. Healthcare facilities, transport, water, etc. And it's also very important in tracking environmental health and degradation at a local level. Now, GIS also makes it very convenient to collect data. This is something that, it took me some time to realize, because traditional data through questionnaires and so on, even if it's, through a cell phone, very hard to collect. But GIS data, much easier to design data collection. And so it can become really a part of education, literacy, and so on. Now, the surprising thing, which I became aware of only when I started getting into this, is that a huge amount of GIS data is publicly available. And this is typically, internationally. And it's a major gateway, therefore, to data literacy and data citizenship. And there's also very powerful open and free software to process such data. It's easy to learn, surprisingly, and it's well within the reach of high school students. And not only that there are a number of great learning resources with excellent teachers, which are available freely on the web. And we look at some example illustrations. So I'm going to look at two kinds of software and give you a feel for what could be done and what one can see for this. So the first one is called Google Earth Engine, and you just have to log in. Everybody can get free access by registering and getting a login. And you get access to lots of data. You get access to a lot of storage and computing power, all free at the moment at least, and probably will continue, and especially for education purposes. Okay, so what does Google Earth Engine really provide? And you will be shocked at the sort of power it has and access. So you know that satellite data has been collected continuously for close to maybe 50 years. Some satellite data is for 30 years. And these are very rich data. And nearly all of it, except for some very specific kinds of data or very high resolution maps, nearly all of it is available publicly. And these are collected by agencies like NASA, European Space Agency, ISRO, and so on. And now what Google Earth Engine provides is that it provides an interface to this data. It gives you access to this data in a very convenient way and allows you to visualize, process this data, and to make even transformations, compute some things on it. And it's also got a distributed array of servers which can do very fast computations and very quickly. Very deep, powerful computations, and all of this is available. So nothing really happens on your own machine or your device, but it also happens at the back end, which makes it very powerful. Coding is easy to learn within the reach of high school students. And a user can go deeper. So complex, powerful computation techniques. So this is a vast area. It's even has commercial value. So if you wish, you could even you learn something from the point of view of getting a job and so on. So even from that point of view, it's quite useful. Okay. So let me show some example. So here is a nice example. I don't know if you can see it. Is this visible?
Yes, sir, it's visible.
Can you guess what it is? Varsha, what do you think it is?
Satellite data, like.
Yeah, so this is an actual satellite imagery. I mean, it's not one image. It's a kind of averaged image over 1 year. It shows the night lights over India, over this region. And can you guess which year this is? Okay, this may be difficult. So this is from the year 1993. So this is, so I took this data and I sort of asked Google Earth Engine to make this map. So it's made this map and by putting this data. And so even this data set from 1993 onwards, it's available for every year. In fact, even for every month, you could say. But because of clouds and so on, it's better to take a yearly average from the best images. It gives you a picture of the night light. And night lights are supposed to, artificial lights are supposed to be strongly correlated with GDP and so on. So this is one picture. Here's another picture. So this is somewhat different from the other one. I told you that this is 1993. Now this is a composite picture of 3 years, 1993, 2003, and 2013. And it's what's called a false color composite. It's very interesting. You can say that the 3 years are separate images and they have been given different colors. So the oldest one is given, so the newest one is given red. The in-between one from 2003 is given the color green. And the old one from 2000, from 93 is given the color blue. So it's blue, red, green, and blue. Red being the latest, and green and blue being older in that order. So if you see, you get a red tinge of this map on the whole. So what can we infer from that? I think many of you will guess. Red being the latest one, it means that the nightlight has expanded. So the red areas that you see are lights from the year 2013. And if you see white light, it means these are lights which are present for all the 3 years. So RGB, red, green, and blue. And that combines to give you the white color. That's a kind of additive color composition. And so the white areas are areas which are sort of been lit through all this period, and the red areas are relatively more, so newer areas. But very interestingly, you will see that there are also some colored lights here and there. I don't know if you can see this, but let me see if I can zoom in. Can you see this now, the colored lights? No, I think this is just a zoom for me. So maybe you can't see it. So let me go to the next slide. Here's a zoomed in picture of this. And you can see that this is actually off the coast of Bombay. You can see the border of Gujarat, Bombay here, very well lit. And then there are some green and red and blue lights here. So the blue light, for example, there's one pure blue here. The blue light means that it was there in 1993, but then abandoned later on. So there was no lighting after that. And typically you will see this in oil rigs or mining areas which are being active and then abandoned after a while. So this is, I'm guessing this is Bombay High. And that's a very interesting story if you dig into it. What is the story of Bombay? And you can see that the different colors show probably that some activity was there and then it was abandoned later on. So this is a map. All of this is created purely by using Google Earth Engine. So can you guess what this is? This shows northern India region and even some part of Pakistan and so on. And you can see New Delhi here at the bottom closer to the bottom, little to the right. And so what is this, sort of patch here? Any guesses?
Agriculture, like barn.
Okay, so there is some text on this thing here.
Yeah.
You can
Got
guess
it,
this
yes.
text. So Moody's refers to a particular data set. It's, I think, a moderate resolution spectrogram of some sort. And it gives you, it's a picture taken of burned areas. That is, areas which have been burned out. And so the land is dry and bare. And it's used typically to identify forest fires, effect of forest fires, and so on. And this is a picture taken on a single day. It could be 2 or 3 pictures combined of a particular. The date is 1st November 2021. And this is a direct. I must say that there are 2 layers. One is the Google Map layer. That's not a picture, but the brown part is a picture. Since I've taken a screenshot, I'm not able to show the layers separately. So now you can possibly guess what happens in November and what region this is. Any guesses?
Punjab and Haryana.
Right, it's mostly Punjab and very little of Haryana. And it shows, in fact, the impact of farm fires after they've, burnt out and gone. So these are the burned areas, burned fields, which are, bare and uh, so on. And you can see that almost all of it is just restricted within the state of, within Punjab. I mean, I don't know the geography very well, but it looks like even in Haryana, there's not much. So it's largely, so it gives you an idea, at least on that date, what is the extent of burnt areas. Okay, so that's a screenshot of, so is someone saying something? Okay, so that's a screenshot of so you do this on the web browser, and this is shows you the sort of code. It's just a few lines of code to get those maps and to take collect those data and so on. So import that data set. So the Google Earth Engine directly allows you to import many of these data sets without having to download them. It has them stored somewhere, and it can just load it for you and do all the processing. Okay, so that's my first example of software. And I have another example, which is the QGIS, which is desktop-based software, which you can also use to process all kinds of data locally. And I don't know how much time we have. So let me take a pause and see if there is time for, yeah, this is stubble burning. And somebody guessed, yeah, that's stubble burning in the region of Punjab. Not forest fire, I think.
Ravi,
Okay.
maybe in 5 minutes, if you wind up, then you can take some questions, 5, 7 minutes.
5, 7 minutes to wind up. Okay. So then what I will do is I will just.
If the data is very important, then you can take 10 minutes if all the participants are fine with that. And then we can spend half an hour at least on question answer.
Okay.
Comments.
Okay. Sure. So let me anyway show it, just one of them, which is all right. So this one. Okay. So this is something called QGIS, which is a desktop-based software. Freely, it's open source software. You can download it freely. And so let me. So this is just a map. So when you open the software, it gives you just a bare canvas like this. And I don't know if you can see on the left. Let me see if I can zoom in. Can you see it zoomed in now when I do this?
Yes,
Or
sir.
yeah, zoomed in, right? Okay, good. That's helpful. So there is a kind of panel here from which if you double click Google Maps, you get Google Maps. So that's what I've done here. And you can get that layer. You can make it visible or invisible by clicking this box here, which I've zoomed into now. So if I click it, it comes on. If I click it again, it becomes invisible. So I can show and hide various layers in this. So this is the basic layer, let's say Google Maps, and which shows roughly the Delhi area. And now I can show, I have something called a shape file of Delhi, which I can load. I've made it slightly transparent. And so that gives you the boundary of Delhi. I think this is the Delhi NCR, but I'm not sure. I mean, the Delhi state maybe. I'm not very clear about these classifications.
It's Delhi only. Yeah,
Delhi only, right? Yeah. Okay. So now, so this layer shows the Delhi. If I hide the Google Maps, you'll see the exact shape of Delhi. And the boundaries which are shown inside are the districts. I think they're districts, whatever they're called. So this, for example, if I click on it using this information tool, it'll give me the name. Sorry, I have to select the layer. I click on it. And so it tells me that it is Northwest, the district. And this is North Delhi. I don't know if you can see that legend here. I've zoomed into that. This is Northeast. And so various districts of Delhi are also shown. So this is called a shape file, and you can download it from the internet. There are many people. This is downloaded from some official, I think, site. And so it can be easily downloaded. So it's another externally loaded data. So I've got Google Maps here. I've got the Delhi shape. And the other data I've loaded here is those red dots. I don't know if you can see them now. So if I hide this. So what do you think these are? If I enlarge this, you will know what these are. So you can see that layer. Can you read it? Here?
Mohalla clinics.
Yeah. So this is the location of the Mohalla clinics as per some website. So so you can load this as another layer. So there are three layers here: the Google Maps layer, the Delhi map layer, and the location of the Delhi Mohalla clinics, which are all points. It's very, so what, this is something that I'm doing now, but if you look at it, all of these is information, and this information is represented in mathematical form, typically as in vector form. So as a set of data points, etc. I'll not get into it now. Someone has a question, we can discuss that more. So I've loaded three pieces of external data: Google Maps, Delhi map, location of Delhi Mohalla clinics, and there's a fourth one, which is very interesting. So let me show that, which is this layer, which looks like some dirt has been smeared on the map. But that's not dirt, it's actually some information. And that actually shows you the population density of this whole region. So if you zoom in a little bit, you can see that if I zoom right inside, you'll see, in fact, that's JNU area. And you can see that they consist of small squares or pixels. Each of those pixels has a value. And if I click on this pixel, it gives me, sorry, I have to choose the, now let me click on this. And it says that it's the population, and it gives a value of 23.13. I mean, of course, population can't be in fraction, but since it's doing some calculation estimate, I'll explain this later if there's a question. So that shows the population at that point. You can go somewhere else and also click, and it will show you the sort of data at that point. So let me click here. That is still showing the same value, but it could show different values at different points. There's no data when there is, it's not a built up area. So this one is showing 29.6. Here it's showing again 29.6. Here it might show on 23. So there are different values. So these are all estimates. So you get this data. This is also very high resolution data, which is available online. So you can take this. So what do you do with this? Now, what I have done is that, let me go back to showing the Mohalla clinics. You can see the red dots, which is Mohalla clinics. What I've done is I've created a molar buffer area around the molar clinics of 1 kilometer radius. So these circles that you see are 1 kilometer regions around the molar clinics. And then what you can do is you can find the population that lives within that 1 kilometer radius. And that's what this layer says. So if I click on that layer and you get the information, so it tells you that the population for the molar clinics is 5393. So it's 53 lakhs 93,000 roughly. So about 53 lakh people live within a 1 kilometer radius of the molar clinics, which gives you an idea of the sort of access that is possible. And if you compare that with the Delhi population, so I've got the Delhi population here. Of course, here it gives the population by district. So I've taken all the districts and added them up, and you get a population roughly of 1.9 crores for Delhi. And so you see that the population which is served by the molar clinics is roughly about 1/4 of the population. So that's 54 lakhs. It's a little over, a little over a quarter of the population is served by that. Okay, so this is an example of the kind of analysis you can do. There are 2-3 other sorts of analysis which I would have liked to show if I had time, but that's, one shows the accessibility of the metro stations by doing the same thing, drawing a 1 kilometer buffer radius and so on. So, but there are many interesting things that one can do into maybe agricultural productivity, maybe the sort of access to public health, healthcare, transport and mobility, all sorts of things. So that's just an example. So let me stop here and open up for questions.
Thank you, Ravi. I think this is a very, very exciting session. It just borders on our political psychology that some of us do on a regular basis. It's wonderful, actually. So we open the session to question answers and also comments. I have throat infection, so I had requested Varsa to moderate this session. If I speak a little longer, I'll start coughing and I'll disturb the session. So you can type your question in the chat if you want. You can also unmute yourself and ask. And both Varsa will help Ravi in reading the questions. And so Varsa, can you please take over from here?
Yes, please, ma'am.
Ravi, Varsa will moderate. Fine. So please, it's open to question, answer, and comments now.
So let us start with Shruti. Shruti has posted a comment and a question. So her question is, one way in which data and education are intersecting today is through the datafication of students themselves through government data gathering systems, example SATS in Karnataka, and private edtech companies. What are your views on this? The edtech companies and the government collecting data and the students being datafication of the students themselves.
Thank you, Shruti. This is interesting to me, but I'm not very aware of this. Of course, this would be hugely important, looking at all sorts of data within the domain of education, and especially the data about students and how that data can in turn be used to control them. But I'm not very aware of this data, where it's available and so on. So one could, but I'd be interested in knowing more. So if you have some more information to share, you could do that, Shruti, either in the chat or you can unmute and speak.
Yeah, so hello. Yeah, this is Shruti. So SATS is a student achievement tracking system. It is a system that government schools have been following for some years now. All students, all scores, summative and the summative and the, what is the other thing? comprehensive, all their scores,
Formative, yeah.
formative and some everything, attendance, everything, socioeconomic data, everything goes on to this system, and now it is being implemented for in private schools also. And
I think we lost a voice, no?
Shruti, we've kind of lost you. Shruti, can you hear us?
one has been completion of age 6 for first standard has become mandatory, and that is because the school will not be able to enter your data at all in the SATS system if you have not completed age 6. So and then of course there's a lot of edtech companies today providing all sorts of solutions to schools in the form of smart classroom, smart curriculum, smart textbooks. So what is happening to this data, who has access to it, and how is it being used, are all I think open-ended questions that we need to look into more carefully.
Completely agree. I think we should be aware of it, and I don't know how much of it is accessible, but I think the DISC data and so on are available in the public domain. This may not be, but it's worth investigating. Thank you for that.
Anyone else? Whoever has some thoughts to share any of the topic that Sir has raised today. Or maybe we can take Anush's question in the beginning. Okay, Jeenat has asked, how precise and correct are these satellite data sets?
So the satellite data, it's very interesting, and you will be really surprised at the amount of data and the precision. First of all, they all images, right? So they are, first of all, reliable, and one assumes they've not been, manipulated. And of course, there is some basic processing that you have to do because the satellites are collecting above the atmosphere. So they do some atmospheric corrections, which are algorithms which are developed over time, and they are fairly reliable. And of course, modern satellites have extremely fine resolution, and you can really see very clear pictures. If you go to Google Earth engine and load pictures, the visible, I mean, ordinary pictures visible to the human eye, kind of those sort of cameras, you will find are even greater resolution than what you have in Google Maps. And of course, you can imagine how fine the resolution will be for military-based data collection and so on, which we don't have access to. The public won't be able to access that, or some forms of proprietary data. So they're really precise and correct. And the interesting thing is that not only visible light spectrum, so the entire electromagnetic spectrum, not entire, but a large part of it can be captured in various kinds of cameras. And these are over various bands. So many of this information is useful for other sorts of things. For instance, you can directly infer the kind of land use based on moisture, based on temperatures, and so on. So surface temperature, various other features, you can estimate built-up areas very clearly. So all of this information, it's quite fascinating. And because they're available in multiple bands, and you can integrate information across the bands, so it's very, very reliable, I would say, much more than, and it's not subject to distortion of data, like if you collect data on the ground. It depends on how accurate those data collection instruments are, the field staff are, and so on, and the respondents. So this is, in some sense, objective data. And of course, interpretation needs some processing, but all those tools are available. And it's quite surprising how much of this one can understand and process. And they're available over long periods of time, 3 to 5 decades typically.
Thank you, sir, for your answer. Anyone else? You can raise your hand. You can mute yourself and ask your question.
Can I ask a
Yes,
simple
please.
question? Ravi, of course, it's really fascinating. And I just have two quick queries. One, when you were showing the data, the pictures of Mohalla clinic and the concentration of population and how they sort of overlap, and okay, that's the data. It tells us something. What more do you want to say on the basis of these two data, and what other kinds of data you would like to bring in to generate a particular kind of, data literacy? Okay, that's one. The second question is that yes, one does understand that IT, the AI is taking over and creating a lot of affordances of the kind that you just discussed. So anyway, we're in that state. So why not use it for data citizenship? And you're obviously talking about some kind of critical citizenry. If we know how to read data, then we also know what's happening in the state. So if you really want to intervene, what kind of data, what kind of literacy, data literacy you would like to create at what levels? Like suppose at secondary or high school level, what kind of exposure our students should get, and at higher education level, what kind of exposure our students should get. And also we have a very active civil society which can play a major role in reading this data and then talking about certain kinds of situations, using this data, because these are evidences. So what kind of intervention you would expect civil society to make? And to do that, what kind of literacy even civil societies need, and how does one arrange that? I mean, they would be doing so many things so much on their own. They have some training, some capabilities, but suppose you want to intervene, what kind of suggestion you have for, I'll not say the state, but for all of us, yeah.
Yeah. So let me take your first question, which is somewhat easier. So we did a very bare minimal exercise, right? So took Mohalla clinics and drew 1 kilometer circles around them, and then found out how many people live in that, which is, simple. So what can one learn from that? So this, I imagine, would only be the start of some sort of an inquiry project, which can combine many things. One thing to do would be to look at comparative data, see the equivalent of Mohalla clinics, primary health centers in other locations, other cities or towns, and see what is the accessibility of that. Even within the Delhi, if you have this data, one could cross-check it with actual footfall in these Mohalla clinics. Are some areas not covered at all? All of these questions could, and does that mean the local people could, or are some Mohalla clinics defunct, not functioning? All of this can lead to interesting discussions and inquiries. You take a completely different example, say water bodies. Water is such a precious resource in many cities, like in Bangalore in particular, it's a very scarce resource. And there are water bodies which have been mapped. There are citizen groups. You can see so water bodies are directly visible on the satellite. And they grow and shrink depending on the season and depending on the year. So you get a very good picture, a time series of this sort of change in the extent of water bodies, disappearance of water bodies, replacement. If you have data from the 70s, you can even, maybe not of that resolution, but at least from the 90s, you can see how many water bodies have disappeared and so become built up areas. All of these things are interesting to do locally. I mean, what I imagine is this also is a form of place-based education. So locally, you do projects and use this data to become aware of what's happening around you. And in that process, also get a feel for what data is, how it's collected, how it's processed, and what might be happening behind the scenes to control our lives. Of course, this will need another component, which is a kind of critical education component to be part of the syllabus and the discussion. And so this leads us to your second question. What do you conceive as a curriculum centered around data citizenship or data literacy? And I'm not there yet. I mean, this is a sort of preliminary work. I think a lot more needs to be done in terms of actual work with students and teachers, which I've done very little. I've done some workshops with teachers. We tried to work with the community along with the Ramanujam, and there were hurdles, like I said. I think there is a certain barrier of crossing the technological barrier in terms of availability of technology and learning to use that technology. Then it becomes, many of these things become accessible and usable. So we are still at a very early stage, early point. I think a lot more work needs to be done before one gets some picture of the curriculum. What is possible, I think there is a good idea. These softwares are very powerful. They require very little coding to be learned because much of the coding is automated and it's done at the back end. So you don't need to learn a lot of programming or something like that. I think that's where we are now, at least that's where I am. And it requires, I think, many more people to take up this sort of work and take it forward.
Thank you, sir. I also had a similar question, but coming from a very different point of view. I had a different context, but the question was the same. How we can address this question, especially in school education, the data and data citizenship. And since school is a place where students have not become a complete citizen, but in the preparation of the citizen, it's becoming a citizen themselves and understanding what is citizenship, what is their place in society. So my question was coming from a certain context. There is a series on Netflix, Adolescence, which actually addresses this question of online bullying and certain misogyny that has been propagated in online space, especially targeting women and children. So my question was, since we are talking about a lot of data of satellite and in school mathematics and especially in statistics, the question is dealt around the data around us and understanding, interpreting, organizing and interpreting and working with it, and through that interpreting the reality, social reality, right? But since one of your slide you mentioned that what happens, how will we articulate this question as citizens when we become the data itself? So in school curriculum, how can we address this question? How we will approach this? Uh, for the students, how they will understand themselves as data, and how will they can approach this question in their school classrooms when the datafication of the student itself. One thing is the state is doing it, and when the online space and the social reality around them is doing it and thinking of them as a data, then how can they understand themselves, and also how can they actually prepare, how can we build uh, awareness around it, right? That's a very advocacy question. I'm not talking about like in general advocacy. It's not an advocacy question how we can build awareness around it, but in school curriculum, how can we address this question of preparing themselves about the data literacy and data awareness? and
So
understand.
so what you're asking is, I think, a very hugely important question. I mean, I've also seen that series on adolescence. Uh, I mean, it's a burning issue, right? In many schools, the
And I
impact.
feel that only mathematics classroom can address this question properly, not the
That is
science or
where
social
I was
science.
leading to. So, I mean, clearly the impact of that is very high, and as educators, we need to address that, right? We need to. So, I'm just wondering where the overlap with mathematics is. I mean, I've not been able to think of something clearly about how to address, say, prejudices on social media, fake news on social media, how you can use mathematical tools for that. I have not been able to understand that. I mean, although it's important and maybe there is some role, but clearly it should be a part of the school curriculum as a whole, which includes understanding of society, understanding of relationships between people, social psychology, and our own emotional lives, etc. This is hugely important, but the overlap with mathematics education is not very clear to me, at least at this point. And maybe, there is something that can be done to see whether mathematics education, learning mathematics can illuminate this in some way. So I don't have an answer to your question at this moment, from the point of view of the mathematics curriculum.
Okay.
Ravi, there is a question from Jayashree.
Yeah,
Yes.
yeah.
He
So,
says,
how did I estimate savings as 25 lakhs?
yeah,
So, this is just typically, I mean, this is purely at some very informal inquiry level. So, you look at people who are in the, say, 50s, 40s, or 50s and see what assets they own in a city like Bombay. So, this was when I was in Bombay talking to people. And the asset they own seem to me typically, they may own an auto rickshaw, a vehicle, taxi maybe, and a small house in a slum. So it's based on that
Okay.
I made an estimate of this 25 lakhs as the
So owning an
value of
auto
that
rickshaw
asset.
could be actually, it might be about 3-4 lakhs or something like that today. An auto rickshaw is about
Less,
three
I
lakhs.
think. A used auto rickshaw may be a little less. But then you also pay for the license and all that adds up. So maybe about, 2.5, 3 lakhs. You could sell it. So that would be the worth of. And a
There
small
is.
home.
But again, I mean, one thing I'm really thinking is now the
Mm.
health and education things have gone up from the early 90s to now. It is, I think, exponential this thing, right? I mean, education has become so expensive today than it was, and also health.
Yeah, yeah. So I think the expenditure, so the net savings might have gone down,
Oh,
be
yeah.
going down drastically
Imagine the
because as things become, especially education becomes expensive. You're right. So these things are, in fact, are data we should collect and understand. How much, because I know nearly everyone who's at an income level of, say, below 50,000 per month per household is in debt. So this is like a gift, you could
exactly.
say. And understanding this is important for, I think, the whole of society, and certainly should be somewhere a part of the school curriculum also.
So, thank you, sir. Next question is from Chandra. Sir, could you share some software like QGIS so that we
Yeah,
get an understanding of how data can be used? These tools
yeah,
can prove to be a powerful tool
yeah, yeah,
to understand data and real world effects of the data.
yeah. So I think these two are really sufficient to begin with. They're very, very powerful. Google Earth Engine and QGIS both are free and open source software. In fact, Google Earth Engine just runs on the browser. It's all the computation is done backend. QGIS you download on your machine, computer, so it could be a Mac or Windows or Linux. It's available for all of them. And there's an excellent set of videos. In fact, one of the really good pedagogues I found, educators, is somebody called Ujjwal Gandhi, and Spatial Thoughts. So Very nice, very accessible tutorials on YouTube. Also, you can download it as a PDF, the whole thing, and it's freely, openly available. He really seems happy to share whatever he has generated in terms of learning. He also has paid tutorials and courses. Of course, they're aimed at people who are learning to as a commercially marketable skill, but it's something that's also useful for teachers, and at least the basics one can learn. And this is if you just Google this, I think you'll find lots of learning material. Yes, both for Google Earth Engine and QGIS, and that's where I initially learned from. And I think a few days, weeks investment will make you quite capable, I think. So, yeah, that's in response to Chandra's ma'am or Chandra sir. I don't know.
But he also suggests looking at Ujjwal Gandhi's special thought. I don't know about it. It seems it's an open source learning
Yeah,
material.
I've just typed it in the chat. Yeah.
Oh, you typed it. Okay, sorry.
Yeah. I typed it. That's a good thing. Yeah. I think mathematics is still considered neutral and abstract. Anushri has asked. Absolutely right. And so I think there's overlap with, between mathematics and social reality is something that's really under the radar and not even visible for us. But it's very, very important that we start talking about it, start doing some exercises as educators with teachers and students. And there is interest for it. I mean, if you start it, there will be takers. I think that's, yeah. Thank you for that question.
This is very important, actually. So mathematics learning is made very routine kind, it's routinized.
Yeah. All this is thought to be external to mathematics, nothing to do with maths, which I think is a huge mistake. But already NCF, I mean, work by people like Anita, Jayashree, and so many others in the country, others internationally, has shown that this is a very limited and blinkered view of mathematics.
Any more question? Maybe we wind up in 2-3 minutes. We can take one or two last questions if you have. Or comments?
If there are no questions or comments, we will wind up the session.
Yeah, please.
Thank you so much, sir, for accepting this invitation and coming to NMRC webinar. We are doing this series every 50. I mean, we do these lectures, we invite speakers, and we do these lectures every 15 to 20 days. And every session is just filled with so much insights and so many queries, and gives so much space to, think about. I have attended one of your sessions where you already talked about this QID database. And yeah, I did the exercise. So it was, that time also it was amazing. And this time also it opened so many thoughts and ideas, and so much to think about. Thank you.
Thank you
for
for the
joining the session.
opportunity. I enjoyed it very much. Thank you.
We all
Ravi, the center periphery thing, as long as we constantly travel in both the spaces, we are good. And you are bringing that periphery to the center in this talk. I'm really glad to hear it. Also, let us know when you come to Delhi. We don't have money to pay you the airfare, but we can add in some local travel so that you can come to our center and give a physical talk. I mean, face-to-face talk. Same goes for other speakers. Whenever they're in Delhi, we can arrange. So just let us know whenever you're coming. We'll arrange one face-to-face talk. And on this topic, because on this topic, a lot of centers will come forward to listen, like sociology, we have geography department. Two of my friends actually started GIS, 2 decades back, got a huge funding from DST and started it. And I'm sure all of them would be really interested in this. And this geography center, the population study center, is huge. A lot of their students are working on questions of health, education, using GIS data. So I think there would be a lot of interest in a talk like this. So just let us know whenever you come to Delhi. Just give some hours for us. Thank you.
Thank you.
Thank you
Last
so much, sir.
word, Varsa gets. Varsa, do we now close?
Yes, ma'am. We'll close. I'll be here in the session for some time. I will save the chats and everything. Yeah, I have to do
You
the
can
logistic
leave.
work.
So Ravi, thank you from all of us. Varsa has already thanked you. Just
Thank you. Yeah. So I'll take leave now. Yeah. Bye.
thanks for a
Thank you
wonderful.
very much for joining the session. Bye.
Bye.
So we are leaving you to whatever you want to do.